All right, so this performance task is not performance task project, whatever it is here for our cyber class is graphing conic sections. So if you read through the instructions, they kind of give you an idea of what's going on. But we'll just kind of jump right into this here. So for part one, identify key features and graph a parabola from standard form. So we answer the following questions to determine the key features of the parabola based on the equation shown and then graph it. Now, keep in mind that because this is x equals y squared, it's a horizontal parabola and it opens to the right. It's not the one that we're most familiar with that opens straight up. So what is the axis of symmetry of the parabola? The axis of symmetry is going to be the point that goes right through the middle of the parabola, which is this. But for this particular problem, it's been shifted up 2. So our axis of symmetry is y equals 2. All right, we're back. What is the vertex of the parabola? The vertex of the parabola happens from this shift. So I have a 3 with the x value and a 2 with the y value. Reversing the signs on x and y, it's -3, 2. That's where the vertex is. What is the focus of the parabola? If you remember, there's a bit of a form for this. So because we're in the equation or in the form y squared equals 4px, we would say that 4p is equal to 12. So here's our 12 in front. So 4p is equal to 12. I'm good. How are you guys? Enjoy. So 12 is equal to 4p. So because of that, p is equal to 3. So when we put it together, the equation for the focus is h plus p comma k. We know that h is equal to -3, p is equal to +3, and k is equal to 2. So our solution is 0, 2. What is the directrix of the parabola? This one also has its own formula. You know that the directrix is x equals h minus p. So in this case, it's -3 minus 3, which is -6. Sketch a graph of the parabola, vertex, and axis of symmetry. So I believe there's a grid here. Yes, indeed. We know that the vertex is at 3, -2. -3, -2, -3, 2. Good grief, I can't read this. -3, 2. That's your vertex. And then we know that the focus is at 0, 2. And the directrix is x equals -6. And that should be a straight line, even though mine is very, very wavy. And then your parabola passes through the vertex, goes up and to the right, and down and to the right. There we go, there's your graph. Part 2, identify key features and graph a circle from general form. So no longer a parabola, but now we're onto a circle. So we want to write the equation of the circle in standard form. And what we're looking for there is x something squared plus y something squared and is equal to the radius squared. That's standard form. So what do we have to do for this one? We're going to do a little bit of completing the square. So I'm going to get the x terms together, x squared plus 12x. Leave a little space. Then I'm going to have y squared minus 2y. Leave a little bit of space again, and I'm going to move the 12 to the right-hand side. So the reason why we left some space is to complete the square. That's where you take half the middle term and square it. So half of 12 is 6. 6 squared is 36. So plus 12x plus 36. But I can't just add 36 to one side of the equation. You also have to add it to the other. And that 12 is just sitting there. All right, for green, we have y squared minus 2y. So half of the middle term is -1. Square, which is a positive 1, I add 1 on the left. Should do that here. And then I also add 1 on the right. Okay. The reason why we do that is to be able to write it in factored form. So this would be x plus 6 quantity squared plus y minus 1 quantity squared. And then we add up all the numbers on the right. 36 plus 12 is 48, plus 1 more is 49. So there's the equation of the circle in standard form. So where's the center of the circle? That comes from your h and k that are next to the x and y values. So your center is at -2, 1. And what is the radius of the circle? That comes from this piece over here. It's radius squared. So your radius is 7. Sketch a graph of the circle and label the intercepts. So we said the center was at -6, 1. Center. We know that it has a radius of 7, so it's going to come over to here. -6 plus 7 in the other direction is -13. And we go up 7, so we're really going up to 8. And down here to 6. Okay. And then we also want to, well, it says the intercepts. That's not quite what they meant. Just the high and low like we had before. So -6, 8, -6, -6, 1, 1, and -13, 1. And there's our circle. All right. Write the equation of and graphs an ellipse. An ellipse is an oval. So given the foci and the vertices of the ellipse, complete the following steps. What is the center of the ellipse? Explain how to determine this. So the center is at 4, -6. It's equidistant from both vertices or both foci of the ellipse. So because this is -6 plus or minus 9, we just use the -6. Because it's -6 plus or minus 5√2, you just keep the -6. Write the standard form of the ellipse. So we know that A equals 9 and C equals 5√2. Those are the extra distances up here that are added on. We also know that C squared is equal to A squared minus B squared. So we're going to put in some of that information. 5√2 squared equals A squared is 9 squared minus B squared. So 25 times 2, this becomes 50, equals 81 minus B squared. B squared is equal to 81 minus 50, which is 31. Had some incorrect math there in my head. So how do we put all this together for the ellipse? It's y plus 6 quantity squared over 81 plus x minus 4 quantity squared over 31, and it's equal to 1. It's always equal to 1 with an ellipse. What are the lengths of the major and minor axes? So the major one is the longer one, so it's 2a. And recall A was 9, so 2 times 9 is 18. The minor axis is the square root of 31, so we have 2b, which is 2 times the square root of 31, 2 root 31, and then we want to graph this. So you just take all those important points we found up earlier and graph them. So your center is at 4, -6. Center. And we know that we have a major axis at 4, -2. And our foci is at 4, 1. The other foci would be symmetric to that. So that's actually going to be at -4, -13. This is a foci as well. And then your minor axis goes horizontally, and that's going to come over to 8, -6. All right, so how do we graph this? We're 2 above here, we're 2 below here, and we're out here. And this is over at -1.5. All right, just gonna kind of graph those. It's a little tough to get the ellipse perfect, so that's why it's important to label exactly where the center is, the major axis, the foci, all of those things. All right, and model a real world problem. An artist wants to make an elliptical sign out of a rectangular piece of wood. The wood piece has a length of 60 inches and a width of 40 inches. The artist wants to make the largest elliptical piece possible from the wood. Write the equation of the ellipse, placing the center of the origin of the coordinate plane and making the x-axis the major axis. So here's the piece of wood. And we know that it's 40 by 60. So we want the center of the wood to be the center of the coordinate plane. That's what's going on here. So we want the A and B values of the ellipse. So A, the major length, the longer one, would be 60 divided by 2, which is 30. And B would be the shorter length, 40 divided by 2, which is 20. And we know that an ellipse has x squared over a squared plus y squared over b squared is equal to 1. So this would be x squared over 900 plus y squared over 400 is equal to 1. What are the foci of this ellipse? So for this particular problem, we know that c squared is equal to a squared minus b squared. So c squared is 900 minus 400. So c would be the square root of 500, which we can simplify. That's 10 root of 5. So the foci, if we take, well, this one's going to sit on the y-axis. So your foci are plus or minus 10 root 5, comma 0. So how do we graph this? We're at 0, 20. We're at 0, negative 20. We're at 30, 0, and negative 30, 0. And the foci are at 10 root 5, which is kind of between 20 and 25. And then you sketch a graph. There you go, something like that. Part 5, identify key features and graph a hyperbola in general form. Answer the following question. So the standard form of the hyperbola, same thing as we did before, we're going to have to complete the square. And this one will be equal to 1 as well. It's very similar to an ellipse, but instead of a plus sign, we have a minus sign. So I'm going to start with 4x squared plus 8x. And then I'm going to have minus 9y squared minus 36y. And I'll move the 68 to the right-hand side. And then in order to complete the square, you don't want an a term. You want to get rid of this. So not really get rid of, but factor out. X squared plus 2x. Leave yourself some space. Factor out the -9, so I've got y squared plus 4y, leave yourself some space, equals, and this is still 68 on the right. So when I go to complete the square, it's half of the middle term squared, and that's what we add. So half of 2 is 1, 1 squared is 1, so I add 1. And, well, let's put a 1 over here, and then we'll talk about it. And y squared plus 4y, what do we add? Half the middle term, so half of 4 is 2, 2 squared is 4, so we add a 4. But I didn't really add a 1 and a 4. I added 4 times 1. So you have to make sure that that's on the other side as well. I really added 4. And I didn't really just add the 4 on the left set, the right set of the parentheses on the left-hand side, but I really added -9 times 4. So this 4 gets a -9. So on the right-hand side, to put all this together, I have 68 plus 4 minus 36. And now these will factor nicely. So 4 x plus 1 quantity squared minus 9 y plus 2 quantity squared is equal to 72 minus 36 is equal to 36. Okay, now because this needs to be a 1 on the right-hand side, we divide everything by 36. So divide by 36, divide by 36, divide by 36. So I have x plus 1 quantity squared over 9 minus y plus 2 quantity squared over 4 is equal to 1. What is the center of the hyperbola? That comes from directly above, -1, -2. What are the vertices of the parabola? Hold on, please. Mine are a little bit different than yours. Well, here says vertices. I think foci is a better word here. So this would be -1. The hyperbola opens symmetrical to the x-axis. So the foci are in the form h plus or minus a comma k. So symmetric around the x-axis is going to look like this. Kind of looks like two parabolas, but then they have these asymptotes here. So for us, it's -1 plus or minus 3, comma -2. What are the asymptotes of the parabola? Those come from this equation. Y equals k plus or minus b over a x minus h. By the way, if I finish this one out up here, we would have 2 comma -2 and also -4 comma -2. If we plug all the pieces into this equation, we know that k is -2 plus or minus b over a, so that's 2 over 3. X minus h is x plus 1. If you go through those and distribute and combine like terms and solve, you have y equals 2/3 x minus 4/3. And you also have y equals -2/3 x minus 8/3. So this one, there's a lot going on to graph this one. But you would start at the center, which is at -1, -2. From there, your foci is at 2, -2. Your other foci slash vertex on the left is at -4, comma -2. Foci, foci, center. And then you use this box to draw. So we go up to -1, 0, and -1, -4. What did we just call that in the last step? We called those, I guess we call those the foci as well. But you have this little box here. And then with that little box, you actually have those lines that are the asymptotes. So from here to here, and here diagonally. So this just becomes the guiding factor for your parabola. And so it touches the foci, and then it goes up. I said parabola, I meant hyperbola. Like this. And on the left, it looks like this. All right, there you go, graph and conic sections.